Addition and subtraction of sets. Sets can be added and subtracted from each other provided they follow the law of algebra where like terms are grouped. And so instead the like term here would be the expression under the square root. So if you are multiplying a plus a, we see that they are like terms. But then in this case, the square roots are the like terms. So if the term and the square roots are the same, then we can add them. Alright. So usually if you are given a set, we would have to simplify it. And then if after simplifying, we see that two expressions are the same and the square roots, we can add or subtract them based on the operations we are given. So let's see how that can work. Right. So first example, 2 root 5 plus square root of 45. 45 looks to be a number that can be simplified, or a set that can be simplified. So let's see how that goes. When you look at 45, it is actually 5 times 9. 5 9 is 45. And voila, you can see that 9 is a perfect square of 3. It is important you understand or know some perfect square numbers. Based on your level, I would recommend knowing up to at least 15. The square root of 2, 3, 4, 5, 6 up to 15. It will help you to recognize some of these things relatively easily. Okay, so 9 is 3 to the power 2 times the square root of 5. This expression is reduced to this, where 9 is now 3 to the power 2, and then root 5 can't be changed any further. And then from this we can see that the 2 cancels the square, making it 3 root 5, which goes to tell that all of this expression now becomes 2 root 5 plus 3 root 5, because the 45 after simplification is now 3 root 5. So we get this plus 3 root 5. Great. Now what do we see? We have to consider the expressions under the square root. Are they the same? Yes. This is 5, this is 5. And so if they are the same, then it means we can add the terms in front of the set and then maintain the number set. In this case, we add 2 to 3 whilst maintaining the root 5. And so we get this 5 times root 5, or 5 root 5. This is the answer to the question 2 root 5 plus square root of 45. We first simplified this and we got 3 root 5 and realized, oh okay, the terms under the square roots are the same, meaning we can add them, right? So we added the expressions in front, this and that, whilst maintaining the set. And so 2 plus 3 is 5, and then root 5. Alright, let's look at another example. This is straightforward because we can see straight away that this and this are the same. The expressions under the square roots are the same, so we don't have to worry about any simplification. We can subtract them right away. Now this is 2, this is 3. 2 minus 3 is negative 1. And so we get something like this. Usually, like all other algebraic terms, if you find an answer which is negative 1a, you don't bring the 1. You just repeat, you just represent the term negative a, for instance. And so in this case, you don't write negative 1 root 6. We just write it as negative root 6. If it is positive 2, we are not going to bring the 1. Just that for that one, we didn't also bring the positive as well. In this case, it is negative 1 root 2, and so we'll bring the negative root 6. This is how addition and subtraction of sets work. We look at the terms under the square root. If they are the same, then we can go on to add or subtract the terms in front. Good. How about this? Try this and then we can look at it together. Okay. Now this is also straightforward. We have root 3 root 3, then 3 root 3. Now what is this telling us? Like I said, when we're dealing with this simply means there is 1 in front which we don't write. This also means there is 1 in front which you don't write. And so we can see that there is 1 plus another 1 plus 3. Now what is 1 plus 1 plus 3? That is something like this, all root 3. So we get a sister expression when you are solving an algebra question, and then you have something like this, a plus 3a, that is 5a, and that is similar to this. We don't write 1a, we simply write a. That doesn't mean the 1 isn't there, we just don't write it. So similar to this, we have 1 in front, which we don't write, just like if you're adding something like this. Good. So 1 plus 1 plus 3 becomes 5. So we have 5 root 3. Can we see some more worked examples? Yes, let's see. Try this. This is a mixture of both addition and subtraction. 4 root 11 plus root 11 minus 2. Like we earlier said, we look at the terms under the square root. If they are the same, then we can go ahead. Now we can see that they are all the same. The expressions under the square root are the same. Now we look at the terms in front of the square root. You have 4 here. There is 1 here. It is a usual mistake that students omit the 1 here, but there is a 1 here. And so this shows that you have 4 plus 1 minus 2. 4 plus 1 is 5, minus 2 is 3. And so we get 3 root 11. How about this? It is important we first simplify these. I'm sure you do agree. Now, 80 is 5 times 16. 20 is 4 times 5. Then 45 is 5 times 9. If you don't know how we came by this, or if you struggle to come up with these numbers, look at a video on how to obtain this using the prime factorization, and that is an easier way of recognizing which two numbers to multiply to simplify your set. Right, now 80 now becomes 5 root 16. You can tell that root 16 is a perfect square of 4. 4 times 4 gives 16, and so instead of writing all of this, we rather write square root of 5 times 4 squared. The same thing, 4 becomes 2 squared, right? Good. And then 9 becomes 3 squared. Okay, now we know that 4 cancels its square roots, and then 5 still maintain because we can't reduce it. So we get 4 root 5 for this. The same thing happens with this. 2 cancels its square roots, while that of 5 maintains. And so we have 2 root 5. And then 3 also cancels its square roots, whilst the 5 square root is maintained. Alright, so this, the reduced form of this example we were given. And so now we can see that all of them have a square root of 5. And so 5, 5, 5. Now we have 4 plus 2 minus 3. 4 plus 2 is 6, minus 3 is 3. So we eventually have 3 root 5. Good. This video is becoming lengthy, and so it will end here. But then there is more to adding of sets, and so we'll look at some of these nitty-gritty that comes up with addition of sets in the next video. Make sure you check it out.